Right, welcome to this explainer. We're diving straight into the rather shocking realities of global land degradation today, and crucially, how we're actually fighting back. We're talking about a phenomenon that literally impacts billions of lives, fundamentally alters our global climate, and puts global food security at serious risk. It's a story at some pretty vicious cycles of environmental decline for sure, but as you'll see, it's also about some absolutely brilliant, virtuous recoveries.
So let's kick things off with a question that might just flip your perspective completely. Are giant sand dunes actually swallowing the Earth? When most of us hear the word desertification, we instantly picture the Sahara or the Gobi Desert physically creeping outward, just marching across the landscape and burying farms under endless waves of sand. But the scientific reality, which is backed up by decades of research, is actually far more complex and, quite frankly, a lot more urgent.
Actually, you can go ahead and scratch that whole marching sand idea. The United Nations Convention to Combat Desertification makes it clear. Desertification isn't the physical expansion of existing deserts. What it actually is the severe degradation of land in arid, semi-arid, and dry subhumid areas, places we basically just call dry lands. It's the rather tragic process where once productive ecosystems, like vibrant grasslands, lose their vegetation, their soil fertility, and their ability to hold water. And this happens because of a nasty mix of natural climate variations and unsustainable human actions. It is fundamentally a classic double whammy. On the human side, the anthropogenic drivers, we've got things like overgrazing. When you put too many animals on a patch of land, they strip the grass right down to the bare soil. Add intensive agriculture that just strips nutrients, deforestation that removes the protective canopy, and poorly managed irrigation leading to toxic soil salinization, and the land is in real trouble. But we aren't doing this in a vacuum. We're amplifying the climatic variables. Rising global temperatures mean moisture evaporates faster, and massive shifts in oceanic surface temperatures are completely rewiring the rain patterns these dry lands desperately need. The peer-reviewed science really brings this home. If we examine historical rainfall in the African Sahel from 1930 up to 2000, there's a massive, dramatic shift. You've got anomalously wet periods back in the 1950s, followed by absolutely devastating, prolonged droughts in the 70s and 80s. And advanced climate modeling shows this wasn't just a bit of bad local weather, it was driven by the oceans. A general warming of the global tropical oceans, especially the Indian Ocean, along with warming in the South Atlantic, dynamically altered the entire West African monsoon. It just proves that forces happening thousands of miles away can trigger catastrophic, decadal drought cycles. Now this is where it gets incredibly fascinating and a bit scary. It's a vicious cycle known as the Charney-Albedo feedback loop. Here's how it plays out. First, a climate shift or human overworking kills off the vegetation. Second, that leaves bare soil exposed, losing its dark protective cover. This shoots the land's surface albedo right up, meaning it reflects much more solar radiation back into space instead of absorbing it. Third, all that reflection causes localized radiative cooling and atmospheric subsidence, which is basically sinking air. And finally, that sinking air literally stops clouds from forming, reducing rainfall. The degraded land is literally changing its own local weather to prevent rain. It locks itself into a drought. And we really need to grasp the sheer scale of this. Drylands cover roughly 46% of our global land area, and this degradation is currently impacting over 2 billion people worldwide. 2 billion. We're talking about communities whose local agriculture, water supplies, and entire livelihoods are fundamentally threatened because the soil is failing them. When the land gives up, the people face immediate food insecurity, and their local economies just collapse. And if we don't step in and break this cycle, the human cost is going to be staggering. The UN estimates that up to 135 million people could be forcibly displaced by the year 2045. That's purely down to food insecurity, lack of water, and these dry lands just becoming uninhabitable. Mass displacement on that scale inherently fuels geopolitical tension, overcrowding, and severe conflicts over whatever arable land and fresh water is left.
But hang on, it is absolutely not all doom and gloom here. Just as the land can fall into that vicious cycle we talked about, we are now learning how to trigger a truly virtuous cycle of recovery. Humanity is actually pulling off some monumental, science-backed efforts to heal the soil. By bringing vegetation back, we can reverse that albedo effect, anchor the topsoil down, lock away carbon, and actually coax the local water cycles back to life. We've got some massive global initiatives driving this forward. You've got the Bonn Challenge, aiming to restore 350 million hectares by 2030. Then there's the AFR 100, targeting 100 million hectares specifically in Africa by 2030. And of course, the absolutely phenomenal Great Green Wall, an 8,000-kilometer mosaic of restored landscapes stretching right across Africa to restore 100 million hectares and create 10 million jobs by 2030. These aren't just simple tree planting exercises, they're comprehensive programs restoring soil health and combating climate change all at once. If you want to see some real-world proof that this works, look at Kazakhstan's Northern Aral Sea. For decades, draining the Aral Sea was seen as one of the most disastrous human-made environmental blunders in history, turning it into a toxic, salty wasteland. But recent restoration efforts have literally brought the northern section back from the dead. They've reclaimed 870 square kilometers of dried seabed. The water volume is up by an astonishing 42%, and the salt levels have plummeted, decreasing fourfold. It is brilliant proof that even the most severely degraded ecosystems can bounce back. And it's happening in South America too, over in Argentina's Gran Chaco. Now, this is the continent's second largest forest after the Amazon, but it's been getting hammered by deforestation for agriculture. Today, thanks to groups like the Nature Conservancy, local farmers are pivoting to regenerative agriculture. They're using smart cattle enclosures and science-based farming to actively restore the habitat. They are proving, on the ground, that you can sustain and even improve food production without knocking down trees, which protects biodiversity whilst cutting greenhouse gas emissions. So, as we wrap up this explainer, I want to leave you with a thought. We've just seen exactly how the Earth dries out, and the phenomenal, back-breaking effort it takes to bring it back to life. The health of our dry lands is completely tied to the food on our plates and the stability of our entire climate. Knowing how fragile yet incredibly resilient this planet is, what role are you going to play in supporting the sustainable future of our soils? Everything from the products you buy to the policies you back ripples across the landscape. Thanks so much for joining me, and keep learning.